All right, this is the proving trig identities. We'll do question 3 and 4 in this video. So number 3 says sine squared minus cosine squared equals 2 times sine squared minus 1. If we look at our toolkit, we have something that is kind of subtracting the sines and cosine squareds, but it's in the different order. So it's going to be actually easier for us to not try to switch this around and make things negative. Because we don't really want to have this 2x on the inside. So same thing with, at changing into these and into that, it's a little bit more complicated. So let's use, let's change maybe this, let's see what we're trying to make it turn into, I guess. We want to have sine in our result. So let's see if we can change this cosine squared of stuff into something with, that if possible. So cosine squared, if we look at this, this is 1 minus sine squared. That's a possibility there. So we have sine squared minus 1 minus sine squared of x. We're trying to make it become this side. So let's see what happens. We're going to distribute this negative 1 through. So I have sine squared of x minus 1, and then positive sine squared of x. I mentioned before there's several different ways to do this, so if you wanted to change the sine squared into something else instead, it would also work. So from here we have a sine squared plus another sine squared that makes 2 sine squared of x, and then minus 1, which is, again, that's what we wanted, so we're just proving that that left side is the same as the right side. Okay. If we look now at question number 4, we have sine over x, or sine of x over cosine of x plus cosine over sine equals cosecant times secant. These are the reciprocal functions, if you remember from earlier in the week. So let's start again. This side looks a little bit more complicated. I'm going to start on that side, and we have fractions that are being added together. So we need a common denominator first. So let's try to make a common denominator. So sine and cosine would be in the bottom. So I'm going to multiply this first fraction by sine of x on the top and on the bottom. And then this fraction over here, I'm going to multiply by cosine on the top and cosine on the bottom. So we're dealing with the left side still, if that's unclear. So this sine times sine is sine squared. And then cosine times cosine is cosine squared. And now the denominators are just both sine of x and cosine of x. I moved that into one fraction all at the same time, if that's all right with you. So then we see the top, this is the main Pythagorean identity here. Sine squared plus cosine squared, that's worth 1. So the top of this fraction is a 1, and then we have sine, and then we have cosine. And what we can do is we can split up these sines and cosines. So 1 over sine of x times 1 over cosine of x. And 1 over sine of x, that is the cosecant function. And then 1 over cosine is the secant. Okay, so we see that we get the same thing that we had on the right side to begin with, so we just proved that one as well. Okay, keep on going. If you're struggling with this, it's okay. It's hard for me too, so it's a lot of trial and error, and if things don't work, try again, because all of these should end up working out. Because they are identities, and the left side should always equal the right side, unless there's some sort of typo, but we're trying to look out for that to make sure that doesn't happen. So keep on trying. If you're having a hard time, it's okay. It'll eventually get easier, and this is to prepare you for next year. If you're taking pre-calculus, you'll practice this again, so don't worry.